So, have you ever wondered how they measure the lean angles of motorcycles in MotoGP or WSBK or some other, superbike sports today? Most modern consumer sports motorcycle actually includes this feature already, or you can pay extra to have them included when you buy them. But if you are interested or curious about the specifics on how they actually do it, then let's dive a little bit more to the specifics, right? So in order to get a smooth and stable reading, there are two electronic sensors that you need. One is the accelerometer, which is a sensor that measures the acceleration force or forces to detect the changes in velocity and orientation. Then you also need the gyroscope to measure the angular velocity to detect rotational movement and orientation changes, right? So you can actually find these sensors in your modern smartphones, right? This is how it knows when you're changing the orientation of your screen. It's basically using those sensors, and also for the GPS capability of your phones. But of course, for GPS, you need a GPS sensor, which we're not going to use for this project for now, right? Lastly, you'll need it's called a Kalman filter. It's a mathematical formula that is used to combine the accelerometer data and the gyroscope data to provide a more accurate and stable estimates of the lean angle by filtering out the noise and errors from the sensors. So what I have here is the MPU 6050 with a 6 DOF accelerometer and gyroscope sensor, right? I bought it from Adafruit. I don't know if you can see that properly, right there. I'll get closer with my face. There you go. Yeah, so it's from Adafruit. I'll post the link below in the description. Basically, this is what you need to read, to get those data or to provide those accelerometer and gyroscope data. And to read them, you need a microcontroller. And what I have here, sorry, it's in the already screwed it on the board for a different project, but I'm gonna use this for prototyping it, right? So this is a microcontroller from Arduino. It's called the Arduino Uno R4 with Wi-Fi. So this is what you'll use to read the data from here, and then apply the Kalman filter to read the data, right? That's just for prototyping, right? If you want to use it for production use, or somehow for some reason you want to create an actual product for it, you will need either a custom PCB for your project, or if you just want to use it for your personal use, what I'm going to do is, once I'm ready to put this on the motorcycle, I'm going to get a different Arduino board, a smaller version. Actually, I have one right here somewhere, or I think I lost it. It's a smaller board. It's called an MKR 1400 that uses a SIM card to basically send data out to the internet, right? But yeah, so once you get them all connected, you will write the code. It's a very specific Arduino code. Actually, it's a C++ code that Arduino uses to write the mathematical formula or the Kalman filter to read out the sensor and the data from this sensor, and and basically provide the smooth and accurate lean angle estimates, right? So what I'm gonna do is I actually created a Patreon. It's going to be a paid subscription for a very minimum price. you can subscribe to that, and what I'm gonna do is I'm gonna post a video of the progress for this project here on my YouTube account. But if you are interested to get the like the schemas, the schematics, the code, and the instructions for this, I'm gonna post it all there. And also for the members, we're gonna start doing giveaways, anything motorcycle related, like accessories, parts, and whatnot. We're gonna do giveaways for the members. So stand by for that. And I highly recommend that you check it out. I might also do a giveaway of this sensor, especially once I start putting them all together. And then, I'll document how we install this into the motorcycle. So yeah, definitely check it out. And we'll see you in the next video.